Spirent Communications, NFVI Starter Kit Test Methodologies, Infrastructure Metering Validation, Part 2. Reserve the topology for a fixed period of time, for example 4 hours, and choose the desired cloud on which to deploy this NFVI test scenario. Wait for the full topology to be deployed on your target cloud. Once all the networks, routers, and virtual machines are created, the elements will turn green, indicating that they are up and ready to use. Verify that both STC VMs received floating IP addresses for the external network. To do this, select STCV1 and click on the ports in the left pane. Click the information icon next to VNIC1 to examine the public IP address assigned to this VM. At this time, verify that VNIC2 has been assigned a private IP address. Repeat the process for STCV2. The next step is to create an IP forwarding test using Spirent iTest. Start by opening the iTest development perspective. Next, create a new iTest project. Right-click on the Session Profiles directory in your new project to create a new session profile. Give the session profile a name, for example, STC1 FFSP. Choose Spirent Test Center as the session type. Now fill out the port list in chassis slot port syntax. Refer to the running virtual topology and velocity to determine the public IP addresses of the two STC virtual machines. Save and start the STC session. The STC library will load at this point and attach to the STC VMs. If there are any problems loading the STC library, install the appropriate TCL dependencies and retry the connection. Add a device to each STC test port. A device is an emulated endpoint that generates and receives test traffic. First, select Devices for the first port. Click on Add Device, Host, IPv4, and see that the default values were used to create the device. In the running virtual topology and velocity, select STCV1 VM. Click the information icon next to VNIC2 to determine the MAC address and IP address of the test port. Copy these values into the appropriate fields in the iTest session. Change the name of the device to STC1. Leave all other values to their defaults and click the Apply button. Repeat the process for the STCV2 port, but name the device STC2. Now add two stream blocks in the STC session. First, select Traffic Generator for the first port, and then add Stream block. Accept the defaults for the General and Frame tabs. On the Endpoints tab, choose Bound and find STC2 as the destination. Click the plus sign to add that endpoint to the destination list. Click OK to accept, and then repeat the process for STCV2. Set the frame rate on both stream blocks to 100 frames per second. Do this by selecting Traffic Generator for the first port, then click Port Load. Choose 100 frames per second and click OK to accept. Click the Apply button to commit the change. Repeat the process for STCV2. Now ARP the stream blocks by scrolling up to the All Stream Blocks view and clicking the Start ARP-ND on All Stream Blocks button. Review the Test Center console at the bottom of the screen and verify that all ARPs were successful. Subscribe to the detailed stream results by scrolling down to the Results view and finding Stream Results. Select Stream Results and add Detailed Stream Results as a result subscription. Click the Apply button to commit the change. Start traffic by clicking the Start Traffic on All Ports button at the top of the window and verify that the STC VM ports are sending and receiving frames. Click the Show Results button at the top of the window and choose Basic Counters. Stop the generator by clicking the Stop Traffic on All Ports button. Close the session window and click the Show View button in the iTest development perspective. Type the word Capture in the search box and choose the capture selection from the box below. Click OK to open the capture window. The session that was just executed was fully recorded and can now be converted into a test case. The last session under Today is the session that we will use for our test case. Without expanding the session details, right-click on the captured session and choose Add to Test Case. A dialog box will open where you can browse to the project created earlier in this procedure. Browse to the test cases directory and name the test case. Click Finish and a new test case will open in the iTest editor. Add a parameter to the test case by opening the Parameters tab, shown on the bottom of the window. Add a parameter called Test Duration and give it a value of 10. Go back to the test case editor by clicking Steps. Select the line entitled Start Generator. Right-click on Start Generator and choose Insert Step. A new step duplicating the Start Generator step will be added. Type Sleep into this field and see that the command changes from Start Generator to Sleep. A default value of 5 is used as the sleep time. Highlight 5 and then right-click. Click Insert Parameter and choose the newly created test duration parameter from the list. Select the line enabled Stop Generator. Right-click on Stop Generator and choose Insert Step. A new step duplicating the Stop Generator step will be added. Replace this command with Sleep and accept the default of 5. Run the test case by clicking iTest Run Start Execution in New Window. Wait for the test case to complete. It's expected that the test will complete with an indeterminate result because no pass-fail criteria has been applied. However, there should be no errors. Going back to the test case editor, click on the Show Results line and inspect the response from the command. Ensure that about 1,000 frames are being transmitted and received. Export the iTest project as an ITAR file by clicking File, Export to ITAR. Select the project and choose Finish. Open Velocity and navigate to the Execution realm and go to the Library tab. Click Upload and choose the ITAR file that was created in the last step. Open the active reservation in the topology editor and click anywhere on the canvas to deselect any active selection. Open the Test Cases tab in the left pane and find the newly uploaded test case created in the preceding steps. Run the test and choose the default test duration of 10 seconds. When the test case is finished, the verdict should be indeterminate since no pass-fail criteria has been specified. Open the test report to inspect the results, scroll to the bottom of the report, and verify that the test ports have transmitted and received about 1,000 frames. Now it is time to run the same test for an extended period of time. Most OpenStack configurations use 10 minutes as the salometer polling time. The polling time can be reduced, but for the sake of this procedure, we will assume that the default polling time of 10 minutes is being used. The salometer metering validation test case queries the last packet rate sample from the specified port. For this reason, we will need to ensure that traffic has been injected into the infrastructure for the entire duration of the sample. Therefore, we will run the test case created in the preceding steps for at least twice the polling time, in this case 20 minutes. Run the traffic generation test created in the preceding steps, but this time specify the duration for an hour or so. After at least 20 minutes, run the Validate OpenStack Metering test case. When running the Validate OpenStack Metering test case, You will be prompted for the appropriate test case parameters, including device name, port handle, expected packet rate, and OpenStack credentials. The packet rates we are verifying in this test case are the incoming and outgoing packet rates on the VM's TAP interface. Since we used 100 packets per second as our input frame rate for the traffic generation, we expect the incoming and outgoing rates to be 100 packets per second plus or minus 1%.